All right, there we go. Recording in progress, straight from the computer's mouth. So anyway, thanks everybody for joining. I'm Paul Baylog. I'm the organizer here for the St. Louis Golang meetup. Let's see, we've got my co-conspirators, I guess we'll call it that. Brandon Hunter, who's not appearing online yet, and Siju John, he either. And then Michael Madden here, he's one of our co-organizers as well. And then of course we have our emeritus Sabri Blackman, who's not joining us this evening either. So we all welcome you to the Go meetup, which is sponsored by GoBridge, who's covering all the, well, they're taking care of the Zoom usage and taking care of our meetup fees as well. And CNCF gets an honorable mention here. Once again, I keep saying this every month. I think I need to update this slide because they're not actually covering the hosting fees, but we do cover some of the projects from the CNCF, which of course one is for our speaker tonight. Of course, we're covering ourselves under the code of conduct from both. So just basically everybody be good to each other, be excellent to one another. Let's see. So again, be sure to keep up with us. I've got the shortcut URLs here and in the YouTube channel for those that can't make it live. I'll have this up on YouTube afterwards. I haven't been doing the streaming live on it yet, but I will upload it afterward. So just some events coming up, and I'm really stoked about this to see that hopefully this is still going to be a live in-person event for KubeCon North America coming up in October. So that'll be a fun one in Los Angeles. So the weather will be nice, I'm sure. Registration's opening up later this summer. And I'm sure Charles, our speaker for tonight, will probably be there as well. And GopherCon is coming up once again. It'll be in December this year in San Diego. There's still details coming out about it, but it's going to be happening. We're getting through all this COVID nonsense. So finally, be done with it. So anyway, I don't know. We've got a small crowd here today. Let's see. I don't know if anybody's got any questions or anything where they know somebody's hiring or looking for Go developers or any kind of special training or anything like that. And hearing none from the small group right now, I'm going to go ahead and proceed. And welcome our speaker here, Charles Pretzer. He's from Buoyant, and for one of I guess the caretakers for one of my favorite projects, Linkerd, which I've actually contributed some code to. So I don't know, you guys might have taken it out by now though. So, so Charles, I'll go ahead and let you take it from here.
Awesome. Yeah. Thank you for having me. And I really appreciate, we love that you're part of the community. And so thanks for being around. Thanks for the contributions that you make. I mean, it's open source software, and that just having folks like you who have experience in open source and working with open source really make it great. So much appreciated. And it's great to be here. One of the things that I'm excited about tonight is that a lot of times when I do meetups, I'm talking about this is a service mesh, this is Linkerd, this is how you use it. Tonight, I get to talk about some of the internals. And this is just going to be a super high level overview. Admittedly, I am relatively new to Go. I'll say I'm a Go novice. I've been using it for 3.5, 4 years now. But it seems like every time I go to look at some of our own control plane code, which I'll talk about later, or if I'm just writing some of my own Go code, which is what I'm doing to learn it more, I'm always finding something new, something that I haven't run into yet. And so it's great. So I say all that just so that you know that I'm not an expert, but I love to learn, and I may have questions for you all as part of this. So let me share my screen here and we'll get some slides going. Let's see. Would you mind making,
Oh,
or yeah,
all right. Do
letting
I just
me,
hit the stop sharing?
yeah, I think you just have to stop sharing.
All right. There we go.
Perfect, thanks. So let me find my screen. Great. Okay, so what I'm going to talk about today is the talk that Paul and I discussed is how we go. And this is a kind of a retrospective on lessons learned from Linkerd 1, and I'll talk about the differences between Linkerd 1 and Linkerd 2. Lessons learned from Linkerd 1 that got us into Linkerd 2. And one of the things, as I was developing this talk and writing the content for it, one of the things that got me really excited about it is it parallels my own career. So Paul and I were talking a bit earlier. I did consulting for a while, and I was using a J2EE commerce platform that is just massive. It's owned by Oracle, and that's what I started my career on. So I did a lot of Java work. And Linkerd 1, which is, as we'll see, was written using the JVM. And then Linkerd 2 transitioned into Go, which I'll explain in detail as well. So I just kind of put that together in my head as I was coming up with this, because it's just kind of a fun parallel. I feel like this is how we move through our careers as engineers. We find technologies, they're interesting, we get curious, and we keep learning. And there's always so much to learn, which is, I think it's a blessing. And I hesitate to call it a curse, but it's like, if you have a curious mind, it can be easy to get distracted. So yeah, just a totally random thought, but my background is coming from Java and now going into Go. So one of the questions that I certainly have for this community is, if you have any tips for not thinking like a Java engineer as you're writing Go code, that would be very helpful. I still, every once in a while, have that itch to look for a way to do generics or do some overriding some of my structs. And I have to quickly remind myself that just doesn't work. So again, what I'll talk about tonight is building the Linkerd control plane for Kubernetes. And so let's see, there we go. This is all my contact info. I saw that you had my Twitter handle on your slide as well. We can, if you want to talk to me, we can discuss all this stuff afterwards. If you want to find out more about what I do and why I do it, we can do that. But this is the obligatory, this is me slide. Okay, so I mentioned earlier, in order to understand how we've gotten to where Linkerd is today, we have to take just a quick look back at where Linkerd was originally. As a high level overview, Linkerd is a service mesh, and a service mesh in the plainest of terms was developed for large scale distributed systems to be able to understand the function, the performance, the success error rates for all the different components of a distributed system. So when you consider a J2E application and its massiveness, its monolithicness, and you break it out into a service-oriented architecture, a microservices architecture, there's a lot of all those function calls that were made in process are now made across the network. So a service mesh meshes all of those pieces together by overlaying. It may not be the right term for it, but just for the sake of simplicity, we'll say that the service mesh overlays on top of the, overlay is not the right term. It becomes we have proxies that become part of the network that then handle the traffic within the distributed system so that we can get a lot of interesting information. So I hope that's all I have to say about the service mesh tonight, and I can just focus on the architecture and the code and the things that we've been doing. So looking back, we have Linkerd 1. It was released in 2016, and it was developed in Scala by some folks who previously worked at Twitter in their infrastructure environment. If you remember, circa 2010, there was a common occurrence called the fail whale, where you might go to visit the Twitter site, or you might send a tweet yourself, and you're presented with this some sort of error, usually a 500 level error that says system can't handle this right now. So as part of the infrastructure team, the folks who built Linkerd 1 and Linkerd 2 re-architected that monolithic Rails application and broke it out into a service-oriented architecture. And as a result of that, they needed to be able to understand the performance of each of the services, the performance characteristics, the success and error rates, what we know today as the golden metrics as defined by the SRE handbook that Google has written. So Linkerd 1 was, again, written in Scala, so it runs on the JVM. It used a Twitter library called Finagle for routing, handling network traffic, basically proxying traffic. You can think of it as, it is a proxy. And this is part of the core of the architecture for what will become Linkerd 2. So again, it was released in 2016, also donated to the CNCF in 2016. I think it was one of the first 5 or 7 projects that was donated to the CNCF. And it is certainly the first service mesh to be donated to the CNCF. So there were some trade-offs with Linkerd 1. After some users and even customers ran Linkerd for a year or a year or more in their development or test and even production environments, the trade-offs began to become apparent for the architecture in Linkerd 1. So the first thing that we noticed is that Linkerd 1 as I wouldn't call it a monolithic application, but running entirely in one JVM, at scale, service discovery would tend to slow things down, especially when you have a lot of distributed services and you have proxies, these Linkerd proxies that have to manage those endpoints. You can see that as those scale, you could run into staleness or caching issues with some of those endpoints as they are created and go away in a distributed system, especially if you're talking about something like Mesos or Kubernetes, where that orchestration can happen automatically. So there were some trade-offs with Linkerd 1. The nice thing about it is that it was multi-platform. So you can run it in bare metal as a process. You could run it on VMs. You could run it in containers in so much as if you're an intrepid spirit who likes to run JVM inside of containers, you can do that. There are folks who did it, certainly. And we experimented with Graal JVM for a little while. And as I recall, this was before my time, but as I recall, it was a little premature Graal was a little too new to be able to handle all the resources that Linkerd 1 used. Another nice thing about it is that Finagle had been in use at Twitter for a very long time. It continues to be in use there as far as I know, and the team continues to release fixes and updates and new versions for it. So it was production ready. It continues to be production ready. So it was a good choice. And one of the other nice things is that because we're using Scala, folks could write their own filters, which this allows for things like when a request comes in, you could drop in your own filter so that you could, route based off of header information, or you could do smart routing, or anything that any code that you could write in Scala or Java, you could drop in as a plugin, and you could then have access to the request and manipulate it and do anything you want with it at that time. So that was pretty robust and powerful. The trade-offs there, as you know, JVM is resource intensive. Scaling was a challenge, especially with multiple endpoints as they come and go in an orchestrated fashion. Finagle itself has a pretty steep learning curve around customization. So it is a powerful library. You get control over things like request windows. There's one of the bugs that I first worked on when I got into the project was changing the size of the GRP, or sorry, the H2 window. But at the end of the day, it was really just the JVM that took up too many resources. And so the team took what they learned about how people were using Linkerd and began to rethink what a new, more modern architecture would look like for Linkerd, what would become Linkerd 2. And just as a little side note here, I see my colleague Dennis has joined. Dennis used to live out here in San Francisco, and he is from St. Louis originally, and he's back there now. So I imagine, he actually, now I have to be very clear about what I say, because he can correct me at any time. He'll know if I'm making something up, if I'm saying something wrong. Or another way, what's that?
Oh, no, I was just going to say he's going to be keeping you on the hook here.
That's right. He's going to keep me honest. So good to see you, Dennis. Okay, so that was Linkerd 1. And so as the team began to think about the future, I started thinking through Linkerd 2 and what does that look like? And there were some design principles that went into that. Initially, Linkerd 2 was introduced in 2017, so not long after Linkerd 1 was released. Well, probably 18 months or so. It's not exactly 1 year apart. It was codenamed Conduit. I remember being at the KubeCon when it was announced and being very excited about it. And it represents a complete redesign of the architecture that Linkerd 1 had. So the design considerations that went into Linkerd 2 were around some of those topics that I discussed in the trade-offs earlier. Really, we wanted to have minimal resource requirements. We wanted it to work out of the box, so little to no extra configuration for applications, and certainly no extra instrumentation. So to say that another way, your developers who are writing services should never have to write code to make sure that Linkerd works or to interact with Linkerd. So we wanted it to be completely transparent and unobtrusive. And then just simple. The design should be clear and it should be a joy to operate every day. So taking these in a separate order, for working out of the box, I mentioned that there should be no need to modify for developers to modify service code to use Linkerd. You should be able to take your service with or without Linkerd and it will work. And when you add Linkerd, you would get the benefits of having the service mesh as part of your infrastructure. The other piece is that working out of the box also means building an easy to use CLI that creates the configuration, the Kubernetes YAML with some sane defaults. So a good example of this is there are some ports that shouldn't be proxied. 80 and 443 are two of those. There's some protocols that and this has changed since the initial release of Linkerd, but there's some protocols which Linkerd didn't want to handle initially, and those are things like SMTP or MySQL. But today, Linkerd will handle those it will handle those protocols and let you, again, you don't have to reconfigure anything to use those if you don't want to. I hesitate there just because they may still be added to the set of default ports that are not used. But again, just by saying that there is a set of default ports, what that means is the team has gone through and been thoughtful about what should be configured out of the box so that you don't have to go through and generate your own configuration file to run Linkerd. Simplicity as another design principle. The takeaway here is having a well-defined architecture. And when you think of Linkerd 1, it initially just had the Linkerd that runs in the JVM, the application. And then later Named was added, and this is a service discovery mechanism. So by the time Linkerd in its current form, Linkerd 1 has two applications that you can run. You can run Linkerd by itself, or you can run Named to do the service discovery and have Linkerd pull multiple instances of Linkerd pull from that central service discovery location. Looking at Linkerd 2, that architecture became much more concise and well-defined. So the control plane, which is written in Go, and well, this is this is the lead up to how we got into Go. So the control plane is the part of Linkerd that uses Go, along with the CLI that I mentioned previously. This is a set of components that are easy to understand and troubleshoot. That's the simple part about it. When you are using Linkerd 2 in your Kubernetes environment, you have these components that are running in pods, and you can configure, there's logging that is available, and you can change that log level as you would with any application. And it's clear what each component does. For example, the destination service is the one that's responsible for service discovery. The identity service is one that's responsible for mutual TLS between your applications, or that's responsible for issuing the certificates. The second part of the Linkerd architecture is the data plane, which again, this is, as rethinking through the architecture, we needed something that was going to consume very few resources, be lightweight, be nimble, and not try to do too much. And that was early on in the Rust days. And so the team made a decision to invest pretty heavily into Rust. And as I was thinking through this, it occurred to me, and I'd love to know if any of you all know this, at some point in time, Go must have been at the same place where Rust was early on. And there must have been some folks, a community like yourselves, who decided, this is a good programming language. I like the way it works. It makes sense to me. I would like to help grow it. And so in my head, I could see a similar situation where back in, I don't know, was it early 2010, 2011 or whatever, where Go started becoming more adopted, but it was still young, where folks were just contributing to the ecosystem. And that was the decision that our team, the Linkerd team, made, was Rust, highly performant. It doesn't suffer from the same memory issues that C++ does, but we're gonna have to do some work in order to build out some of the networking crates or libraries in order for Linkerd to make use of it, which the team did, and it turned out to be a great investment. So again, in this history of Go that I don't actually know, I feel like there must have been some point in time where there was a similar decision made by a group of folks who really just loved Go and appreciated it. And so I saved this minimal resource requirements point for the last, because that's really what was the driving factor for using Go inside of, or Go with the Linkerd control plane, and Rust for the data plane. It also, one of the other pieces that made it easy to decide to use Go is that the Kubernetes itself is written in Go. And so we wanted something that Kubernetes engineers were already familiar with, that they could easily jump into Linkerd and contribute if they wanted to. So it just made sense to start using Go. So now when we look at Go and Linkerd 2, there are a few things that I think are pretty compelling. So as I mentioned, Kubernetes uses Go, so it made sense for Linkerd, the control plane, to be built in Go as well. Our CLI is written in Go, and the main interface between the Linkerd control plane and Kubernetes is the Kubernetes client Go package. And that is where we create watchers to listen for events, for things like when a pod is created, the destination service has a watcher that will create an endpoint for a service, as long as it's part of the Linkerd service mesh, and then distribute that endpoint to that address, the port and IP address of the pod, to the proxies, so that they can be aware of it, and if need be, load balance traffic to that that new workload, that pod. Another fun thing that I didn't know before I started working on the content for this talk is the Linkerd Go adoption timeline. And what I learned from it is that, so I started working on Linkerd around 2019. And so what I learned from going through this process and going through the repository and looking at each of the pull requests that involve changes to the Go version or adding Go features is that the team has been very consistent with staying up to date with some of the features in Go. So specifically, we see that in v0.1.0 in 2017 used Go 1.9.1. And in between 2017 and 2019, I don't have a ton of details about how, I know it's in the repository history. I didn't dig too deeply into it, but around 2019, we adopted Go modules, which was a big step forward. And there, I meant to pull this quote from the PR itself, but one of the engineers said something clever about how DEP is not used anymore and good riddance or something like that. So we adopted Go modules in 2019. And then that same year, we adopted or upgraded to Go 1.12, 1.13. And then the following year, we upgraded to Go 1.14. And then last year, we updated to Go 1.16, skipping 1.15. If I remember correctly, and this is where Dennis can keep me honest, I think that we upgraded to 1.16 as a result of client Go or another one of our dependencies also being upgraded to 1.16. So, and for me, that one's an outlier, only because we were forced into upgrading. Again, the team has been very active in making sure that we're staying on top of keeping our Go distribution modern, keeping the Linkerd control plane in up to date with some of the latest and greatest features that are available in Go. So speaking of some of those features, some of my favorite features that we use, I mentioned the watchers that are, and I believe these are all part, actually, I know gRPC server is not, but watchers, I believe, are part of client Go, and the work queues which are part of client Go, were introduced recently as part of the multi-cluster functionality. So that would have been within the last 18 months or so. And then each of the control plane components has an admin server, which is used to check the health, check the readiness and liveness of the control plane components and to get metrics. And so we use gRPC server, which I believe is part of the net package. I'd have to double check that. But that was also used early on. So rather than use an HTTP server endpoint, we immediately adopted gRPC and built our protobuf files definitions so that we could have strict control over the client and server request structures, request and response structures. So those are just a couple. I know that I could add some more features in here, but a lot of them are, as I started going down that rabbit hole, I saw that some of them are actually package based. Like we use Cobra Command, which some folks like, some folks don't. And I think it is a powerful feature for our CLI. It makes it useful to be able to quickly configure commands and subcommands for the Linkerd CLI. And we use the Helm package as well, so for processing charts. So another way of saying that is one of my favorite features is that we can just pull in other packages where we need to. Going back to the simplicity design principle, you won't see a lot of code rewritten in the Linkerd control plane. We'll use the packages that are available to us and then build on top of those where need be. So another one of my colleagues has a really good talk about scavenging for code in the Kubernetes code base, which in my past working on large teams, building Java applications, I remember seeing like a string converter that was existed in 2 or 3 different classes and did the same function, just a couple of different, in a slightly different way. And so to see a team that is really focused on not rewriting the same function 2 or 3 times, and also not writing a function that already exists in a package that we may already be importing, is really powerful. So that is more of one of the design principles of the team, of the Linkerd maintainers. And for me, it's been refreshing to see that. So that's kind of really all I have to say about how we go at Linkerd. I should stop here and see if there are any questions. I should have been checking in the chat to see if anybody had questions, but yeah, for the most part, that's like a really high level of what we do. In fact, Paul, I would kick this over to you as somebody who is a contributor to the Linkerd project. What do you, did I get it right? or what's been your experience with the code base? I think.
Yeah, really no, I mean, yeah, because I mean, so you know, before I started messing around with Linkerd, I mean, I really hadn't had any of the experience with Go myself. You know, I was using that as kind of, I'm a Java guy, you know, so you know, it's all about exceptions. You know, but you know, but no, so I wanted to start playing around. I got involved with the community here with the St. Louis Golang, just kind of attending some of the meetings, and I was kind of like, you know, what is this language? It's, you know, it's the basis for so much of the cloud native, you know, landscape. I mean, Docker was written with it, you know, Kubernetes, Linkerd, all this other stuff. And it was like, wow, this must be, you know, the bee's knees, as they say, you know. It's so yeah, so I got into it, and then yeah, I worked on. It's funny you mentioned the Cobra project. Well, there's also Viper. So I was playing around with that, and then there was a issue with that. So I actually I submitted a patch for that, and that actually finally got in there. And then I was looking around for another project, and that's when I stumbled on Linkerd. And then you know, you guys' community is just, it's very cool. You know, definitely a good group of people. You know, definitely easily approachable, and Slack and all that. And then, but yeah, and then the code was, you guys made it pretty easy to actually contribute. So I don't know. I messed around with, like you were talking about, with the gRPC. I, you know, did some stuff, additions to the proto buffs. Yeah, a little bit in the, I don't even know if it's even used anymore. I would assume for the initialization containers. For the proxies, I believe I did some work on that, but yeah, no, it's fun stuff. I mean, I don't get to use Go every day in my development life, but I do enjoy it when I get to.
Yeah, well, it's very nice and generous of you to say that. We enjoy having you being part of the community as well. So, you know, and that just makes us all part of the larger CNCF community together as well. So yeah, this is, it's fun. If you want to work on what I believe is a really well-structured Go repository, yeah, come check us out. We can put some links in the meetup invite. I think is probably the right place to put those.
Yeah, definitely. Yeah, and that's one of the things too, for anybody that's kind of looking to learn Go. That's one of the big things, is find a project that you either, you know, use and work, or just that you're interested in what they do. Just try to jump in, and you know, hopefully it's as accommodating and a welcoming as how the Linkerd community is.
Yeah, that's and I've seen the team here has been pretty helpful. Just like sometimes I feel like I'm in over my head, and they are very helpful in getting me focused, and, you know, showing me like, oh, well, the function that you're looking for is in this package, which is, you know, it's separate from the package that I'm currently in, something along those lines. So yeah, that is, again, the high level overview. So I'm available to be reached at charles@buoyant.io. You can also find me on Linkerd Slack, slack.linkerd.io. And Paul's over there too. And yeah, come check us out and help us build awesome things with Go.
Yeah. And then, and yeah, I don't know. I forgot to mention, so today I'm drinking Schlafly Berry Brunch Stout. I'm not usually a stout guy, but my brother for my birthday got me a case of this stuff. So it's like, it's not bad. It's growing on me. So two thumbs up. But Charles, I don't know. Did I know we talked. We tried to get you lined up with some sort of a St. Louis beer, but
yeah,
you got vicinity, I guess.
Yeah, so I did try. I did make an effort to get a St. Louis craft beer, which I was not able to do. They just there were 4 or 5 that I found, and the 2 that you mentioned, UCBC and Schlafly.
Yeah, Urban Chestnut and Schlafly.
Yeah, Urban Chestnut. They just don't ship to California.
Yeah.
As you and I discussed before, I did find one from Kansas City, but I felt like that was a little bit of it felt wrong. It didn't seem like it was the right thing to do. So what I do have, speaking of porter, or you've got a stout, I've got this porter here. So this is an Icelandic beer.
Oh, nice.
Yeah, called Einstock. It's one of my favorites. I'm a big fan of the stouts, porters, those kinds of things. Just because, I don't know, I like the heaviness of them. Yeah.
Now, is that Icelandic one made with lava?
Let's see. It's a Baltic porter. It doesn't say, but yeah, I mean, I think it is. I'm going to say that it is. It tastes like lava, that's for sure.
Yeah.
Yeah. No, I hope that, well, if we ever get to meet at a conference or something, we can go seek out some sort of beer. In fact, yeah, if it's in LA, I know a couple of places where you can get a beer.
All right. Well, cool. Well, I'm planning on going to that. That's going to be my goal anyway, to attend.
Yeah.
So and I'm hoping to attend GopherCon too. That would be nice. So, but yeah. All right. Well, let me switch over, I guess, to the screen share. All right. There we go. Because I am a professional here. All right. So let's see. All right, to wrap it up. So we found out, and Michael, I noticed you're drinking some beers too. I happen to notice a brown bottle there. What do you got? Anything good?
It's an IPA from Hawaii. So I have a Hawaiian IPA.
Oh, is it a Kona?
Yeah, it's Kona.
Kona, it's pretty good. You know, and in Charles, that's one of the things too. You can almost go find any kind of beer that's like a I don't know, like a artisan beer or whatever, and it usually ends up being owned by Anheuser-Busch. It's like they buy up everything.
InBev or Anheuser-Busch, I think is right.
Yep. Yeah. So I mean, Stella's, that's that's AB, all that. So yeah, so it's tough. They haven't bought up Schlafly or Urban Chestnut yet. So
not yet. Yeah.
Let's hope not. Let's let the little guys succeed here. So, but yeah. So anyway, for those of you remaining, give us some feedback how we're doing. Is there anything that you'd like to hear us have discussed? Any speakers you'd like us to track down? That can be Go related specifically, or even like in this case where it's a CNCF project, and then, even with our Rust cousins over there, so kind of interested with those guys too, because a lot of our membership is actually in both. I'm myself in the Rust community as well, but I haven't done anything in Rust yet. It's on my list.
Yeah, well, if I can make that plug too, I mean, the team here has 2.5, 3 years of, well, I guess almost 4 years of experience with Rust now. So if there's ever a mentor that you're looking for, this team is among some of the most experienced. So yeah.
Definitely. Yeah, definitely one of the first projects too that I knew of that was using Rust and for those proxies, and that's it's definitely tight code. It's pretty nice. So
I'm still learning.
Yeah. Yeah, me too. I've got a couple books on it, and I just need to sit down and have the time to do it. But yeah, it's one of those things where it's like, okay, if I do that, then I don't know, my wife will end up divorcing me or something. I don't know. So it's less, it's cheaper to not, I guess. So yeah. So, and hopefully we're almost again over this whole COVID stuff. Hopefully everybody's doing well with it, and then just don't isolate alone. Catch up with us on the St. Louis Tech Slack, also on the Gopher Slack. And then, Linkerd, they also have a Slack going for the project. And there's always activity going on there. Now here we kind of talked about it, and since we don't seem to have a full quorum, and it's mostly members of the steering committee, we're going to forego the giveaway of the JetBrains licenses at this time. We'll try to figure out a creative way to possibly hand out some of these things. So we'll see what we can come up with. Try to be creative. And the next meeting is probably going to be July. I'm skipping June there because we don't actually have anybody lined up just yet, unless something comes up. But, of course, we'll notify everyone by the normal channels if we get something set up. So, but yeah, with that, that's all we got. So, Charles, thank you so much again for presenting to us.
Thanks for having me. It was really awesome.
Yeah, no, and then definitely look forward to seeing folks again in person. Hopefully that's gonna start happening soon. And then can have the beers and together. So cool. All right, everybody. Well, thank you. And then I will have this recording up on YouTube. Let's see. I just noticed that maybe I had a notification here. Oh, all right. So good. All right, everybody. Thank you again. Stay safe. And then we'll look forward to seeing you on one of the next sessions. So, all righty. Thanks. Bye-bye.